Hi everyone, this video is to discuss the composition of air, or in layman's terms, we actually would just say the air we breathe. So this entire unit, we're going to be focusing on the lowermost layer of our atmosphere, which is also called the troposphere. So this is about the first 6 miles of gases of our atmosphere directly above our planet. On top of that, we have a secondary layer, which is called the stratosphere. This is where our ozone layer lies. And on top of that, we actually have the mesosphere. So that's even further away from our planet. But for this unit, we're just going to focus on that first top 6 miles or so, which is actually the air that we breathe. So let's take a quick breath here. Okay, in and out. So if you took a very, very deep breath, your lungs can take about 5 to 6 liters of air. So one breath is equal to about 5 to 6 liters in one breath, which is equal to about 11,000 liters of air per day, which is a lot. That's a lot of air that we take in day by day and we actually ingest into our system. And so let's look at a composition of one breath or one inhale. So what we can do here is draw a little pie chart. So we'll just make a big circle, something like this. We'll cut it down into a couple different sections, and then there's a really tiny one like this. Oh, it should be even smaller, but my pen's kind of thick, so just pretend for me here. So this giant one, our biggest thing of air, our biggest molecule that exists in air is actually called nitrogen, N2, and that makes up about 78% of our atmosphere. The next biggest one is oxygen, or one breath, I should say, not of our atmosphere. So oxygen has a concentration or a composition of about 21%. And then this small little sliver right here makes up the last 1%. And that actually is primarily our inert gas, argon, but there's also a little bit of carbon dioxide in there and then some water vapor. And so this is just our global average. So everywhere across the world, this is on average what you would see if you were able to take in a sample from every human's breath. And so, for example, if you live in a city that is really close to a lot of industrial plants or coal plants specifically, you probably are going to have a much, much higher concentration of carbon dioxide in your air. Alternatively, if you live by a very large body of water, your concentration of water is going to change as well. So on a hot day, you might have a little bit less water. On a cold day, you might have a little bit more. It really just entirely depends on the season and what your environment is like at that specific moment. But on average, we generally assume that we have about 78% nitrogen and about 21% of oxygen. But please do note that this is definitely going to change based on your region or wherever you live in your city. And so let's kind of classify this really quickly. So let's just check in, make sure we're all on the same page here. So let's complete the following sentence. So the composition of air can be classified as a what? Complete that sentence using words that we learned from the last module. All right, did we get it? Did we figure out what that word was? Hopefully this popped right into your mind just from our last learning module, and we understood that this word should be a mixture. So now if I pushed you to try to classify this as either homogeneous or heterogeneous, hopefully you would have said it's a homogeneous mixture. So all of those things that I just discussed before are all in the gaseous phase. None of them are a liquid, none of them are a solid, they're all as a gas, and so this would be considered a homogeneous mixture, all one phase. But so now let's move on and actually look at what happens when we exhale. So we inhale in order for our system to actually absorb that oxygen. So we know as humans that our body is highly dependent on the oxygen that we breathe in. So the oxygen comes in, goes into our lungs, it is absorbed through the lungs into our system, and the oxygen is then able to interact with our food or our fuel that we put into our system. It interacts in order to create some carbon dioxide and water, but more importantly, it's converted into energy. So if you wanted to go do a yoga class or a kickboxing class, or you just wanted to run around and do a 40-yard dash, that is where you get this energy from. It's where the oxygen and your fuel, other known as food, is combining to create this energy for you. However, we know that if that is the case, then when we exhale, the composition of air is going to be different. So let's look at the composition of an exhale. It's going to be very, very similar in terms of our nitrogen count, so we're just going to make it just a little bit different here. There's still going to be that teeny tiny sliver, but now we actually have a much bigger section over here. So this section right here, nitrogen, 78% doesn't change. Nitrogen is an extremely inert gas, and our system cannot do anything with it, so we just breathe it in, and we breathe it right back out. The same thing over here. This 1% is still argon, still carbon dioxide. Maybe our water changes a little bit, but not too much. This part right here has decreased significantly. So this is down to 16% from 21%. This is our oxygen. We know this. We breathe our oxygen in, and then our fuel interacts with that oxygen, so we're definitely going to decrease our concentration. However, this part right here, we now actually are going to say is entirely our carbon dioxide. So that's going to come right over here. And this is about 4%. And that's because when our food and our oxygen interact together, we actually produce carbon dioxide, and we exhale a large percent, about 4% of carbon dioxide into the atmosphere. Then, of course, we know that our plants interact with the carbon dioxide, go through photosynthesis, and are able to convert it back to oxygen for us. So the last thing I want to do really quickly is to check in, and let's do one more quick question to make sure we're all on the same page here. Last question I want to ask you is, what is the primary component of air? Good luck.